All right, this is going to be the second video for Notes 37. The second topic is simplifying rational expressions. And basically the idea here is we have rational expressions, which are fractions. So fraction, a bunch of fractions here. Oops. And what I want to do is to reduce these. And here's the thing that you have to know how to do. When you want to reduce a rational expression, you have to look for common factors. And what I mean by that is I need a factor that exists both in the numerator and the denominator. And so I can't just look and say, oh, there's a 4 here and a 36. Those are both, no, you can't do that. All right, these are terms. 4x is a term, 24 is a term, 36 is a term, x squared is a term. You cannot cancel out terms. You cannot simplify terms. You can only simplify factors. So what we're going to do here is I am going to factor the numerator, factor the denominator, and then I'm going to see what kind of factors I've got. So for my numerator, I recognize that 4x and 24 have a GCF of 4. And so that would be x minus 6 left over, right? That's factoring out a GCF. It's factoring like we've been doing for a long time. Denominator, difference of perfect squares, x squared minus 36. I'm going to go ahead and split the x. And when I split the 36, I have to split it using the same value. So we're going to go with 6 and 6 to make the negative 36. 1 6 is positive, 1 6 is negative. Now, I harped on this whole thing about you can't, cancel out except if it's factors. So here's what I'm talking about. You have a factor of 4. There is no 4 in the denominator. So no, we can't do that. We have a factor of x minus 6. Well, guess what? I have a factor in the denominator of x minus 6. So those two factors will completely divide each other out. And so all that remains is the numerator and 4. The 4 is in the numerator, and then x plus 6 is in the denominator, and that is the simplified form for question A. So basic idea, you're going to factor, right? Factor everything you possibly can, and then simplify where possible. All right, so part B, same kind of problem. I'm going to look to factor the numerator. All right, so for this one, this is a trinomial. So I'm looking for things that multiply to negative 6 and add up to negative 1. So let's see, x minus 3, x plus 2. Doing a quick double check in my head, negative 3 times 2 is negative 6. Negative 3 plus 2, yep, that all works out. Kind of similar to the last problem, x squared minus 4, that's a difference of perfect squares. So we're going to go ahead and split the x, split the 4 as 2 and 2, make one positive, make one negative. Now that you've done the harder work of factoring, what I want to do is look to see what can cancel. So I have x minus 3. There is no x minus 3. I have x plus 2. I have an x plus 2. So 1's in the numerator, takes out the 1 in the denominator. So that's totally fine. And then for my answer, I'm just going to write down what's left over. So x minus 3 in the numerator, x minus 2 in the denominator. If you put the parentheses in place, that's fine. It is unneeded here because those parentheses are there to represent that we have multiplication process. We're taking factor times factor. And for part B, there is no more multiplication anymore. All right, so this is what happens when you have a single fraction and a single fraction, okay? Part C, oh, just look at that fun. So what you're going to do is factor the numerator, factor the denominator, factor the other numerator, factor the other denominator, and then I'm going to look across the entire problem and see what factors do I have in both the numerator and denominator. So we've got a trinomial here, so we're looking to multiply to negative 6 and add up to, we just did this one, didn't we? Yeah, we did. I'm like, wait a minute, looks familiar. So x minus 3, x plus 2. In the denominator, I'm looking to see what multiplies to negative 15 and adds up to 2. So x plus 5, x minus 3. Let's see, the next numerator, I'm looking for things that multiply to negative 5 and add up to positive 4. So x plus 5, x minus 1. Yep, that works. And last but not least, this is a difference of perfect squares. You've seen a couple of them already. So x minus 1, x plus 1. All right, that was a lot of factoring. Okay, so one of the things with math, especially when we get into this higher level math, you're going to be doing a lot of factoring. It is a skill that is going to show up in a lot of different types of problems. Okay, so now that I've done all the hard work of factoring, let's see what I can cancel out. So x minus 3 in the numerator can take out an x minus 3 in the denominator. All right, go on. X plus 2, there is no x plus 2 across any of the denominators, so I can't do that. I'll move on to the next piece in the numerator. X plus 5, look, there's a denominator right here that has x plus 5 as a factor. It doesn't matter that these two things are not in the same fraction. Because this is all a big multiplication problem, it is all going to cancel out the same way. All right, x minus 1 absolutely will take out x minus 1 in the denominator. And after all that hard work, all that's left over is x plus 2 all over x plus 1. All right, so that is the final part for simplifying rational expressions. As always, if you have any questions or concerns, please let me know, and I'll see you in the next one.